Hi guys, welcome back. So we're doing some more stuff with triangles today. We are talking about two more different kinds of segments in triangles. We're talking about medians and altitudes. And again, both of these, kind of like with perpendicular bisectors and angle bisectors last time, they came from the same section. So do these. That's section 5.2. Okay? So, diving right in. A median is a segment whose endpoints are a vertex of a triangle and the midpoint of the opposite side. So as you can see here, CD is a median. All right? I think, honestly, you're going to notice between medians and altitudes, they kind of take separate properties of perpendicular bisectors. You know, one is perpendicular, one is a bisector. So this is the bisector one. CD is a median. It passes through this endpoint C as well as this point D, which is the midpoint of AB. So as you can see, and as you probably already know from what a midpoint is, AD is congruent to DB. Okay? It is possible to draw three different medians in one triangle. The medians do all intersect. It always intersects they always intersect inside the triangle. And that intersection point, the point of concurrency, is called the centroid. All right? It's a pretty vocab heavy couple of sections. It just kind of is what it is. But there is a centroid theorem that I do think is the most, it's kind of weird. I'm not going to lie. Probably the weirdest of any of the ones that we talk about. So the medians intersect at a centroid, and the centroid is 2/3 of the distance from each vertex to the midpoint. So here's what that means. All right? P is your centroid. All right? So BL is the entire median. All right? The distance from the vertex to the centroid, BP, is 2/3 of the length of the entire median. So this is the one that I'm referencing when I'm speaking, right? BP is 2/3 of the length of BL. The distance from the vertex to the centroid is 2/3 of the length of the entire segment. All right? There are other things that you can use with this, you know, or there are other things that you can do with this. If you know BP is 2/3 of the entire BL, PL then is going to be 1/3 of the entire BL. All right. And you can also talk about the relationship between BP and PL. We might get into that into one of these examples. I don't know. We will see. Okay. In triangle XYZ, P is the centroid and YV is equal to 12. Find YP and PV. So this is exactly what I was saying before. YV is the entire median and its length is 12. So YP, because it's coming from the vertex, YP is 2/3 of the length of YV. So if you really want to write this all out, YP is equal to 2/3 of 12, which you can easily use your calculator for. It's gonna be 8. Okay? And because that's what I was just saying. YP is 2/3, so PV is 1/3. PV is 1/3 of the entire median. So PV is 4. And there you go. If you're finding two separate pieces of the median, it should add up to the entire median. So 8 plus 4 should be 12, which it is. Okay. You have that NQ, MP, and LR are all medians because you have in the picture that of all of these congruent pieces, right? NQ bisects ML, and so on and so forth, right? 1, 2, 3 pairs of congruent tick marks on each side. So that's how you can tell from a picture if you have medians, even if it doesn't actually say. All right? So what do you know? You know RL is 21. So that's this whole thing. And SQ is 4. That I can mark off. Find LS and NQ. All right. So LS is exactly the same thing we just did. RL is the entire median. SL is from the vertex to the centroid. So LS is 2/3 of RL, which is 21. So LS is 14. Finding NQ is different because you're looking for the entire length of the median, all right? And you're given this piece. But because SQ goes from the centroid to the actual side, this is the 1/3 piece. So I'm actually going to write this whole setup down. SQ, we know, is going to be 1/3 of the entire median, which is NQ. But this is the piece we know, all right? So we're going to plug 4 in here. 4 is equal to 1/3 of NQ, okay? So how would we solve this? Well, I mean, technically you're dividing both sides by 1/3, or if you're doing this by hand, if you remember from middle school, dividing by a fraction is multiplying by the reciprocal. So 4 times 3, NQ is 12. Okay. The segments in blue are the triangle's medians. Find x if NG is 3x minus 2 and ND is 2x plus 2. Okay, interesting. More variable stuff, but the exact same thing that we just did. You know, ND is the median. NG is from the vertex to the centroid. So I'm going to write an expression like that too. NG is 2/3 of ND, right? Right. Yeah. So if we plug all of the expression stuff in, 3x minus 2 is equal to 2/3 of 2x plus 2. Now, there are multiple different ways to solve this. You absolutely could distribute the 2/3 into the 2x plus 2. That's going to get you some pretty not horrible fractions, but you're going to get fractions, and no one really wants to deal with those fractions. So if we kind of do what we did before, and we divide both sides by 2/3, everything by 2/3, what we can do, like, we're going to multiply. That's the same thing as multiplying by 3/2. So this cancels out, and if we multiply by 3/2 instead, that might get us some nicer numbers. I don't know. So 3 times 3 over 2. Oh, okay. Whoops. Whatever. I tried. You're going to get terrible numbers, I guess, either way. So this is 9 over 2. Well, I'm just going to follow through with this because I already did it. And then 2 times 3 over 2. That'll probably get you something nice. Yeah. 9 over 2x minus 3. Whoops. Whatever. We can handle it. Because then it's just solving the same way. You know how. So this is plus 3 is 5. 9 over 2 minus 2 is 2.5. So that's 5 over 2x. When you divide by 5 over 2, this I'm just gonna kind of 5 divided by 5 over 2. Yay! Okay, a nice answer. X is 2. Woohoo, we did it. Okay. So the whole point was that I was trying to make with all this up here is regardless of whether you distributed the 2/3 in or divided it and then multiplied this by the reciprocal, you're still going to have to deal with fractions at some point, but this is still a level 1 class, so fractions. We deal with them, we know how to handle them. We're going to handle them. Okay, so this is the fun stuff, if you didn't already think all this was fun. There were some questions like this on your last homework assignment that involved finding the circumcenter. I don't know if you ever had to do stuff with finding the incenter. But sorry, something on my table is shaking. That's kind of like the same thing that we're doing here, you know, sort of, all right? Centroids, so we're talking about medians, right? So medians have different properties than perpendicular bisectors. Centroids are not necessarily perpendicular. They just pass through the midpoint. All right. So what we're dealing with here, we would still need to write the equations of your 3 different medians and figure out where they intersect. But writing the equations, again, from Algebra 1, you're going to need a slope and a y-intercept. So, or, in the majority of cases, a point. So what we can do, let me actually pull my median picture out for reference. There we go. So we want to write the equation that passes through one of the vertices and the midpoint of the opposing or the opposite side. All right, so if I talk about that in terms of this problem, let's say we're talking about like xy, right? The median of xy has to pass through the midpoint as well as point Z. All right, so those are the 2 points that we're working with. So we're going to find the midpoint of xy first. So -3 plus 1 over 2, 15 plus 5 over 2, that is -1, 10. That's the midpoint of xy. Okay? So this is the point that we're going to use in a little bit. But how would we find the slope? It's got to pass through this point and point Z. All right, so we're finding a slope between these 2 points. So that's 10 minus 10 over 5 plus 1, which is 0 over 6, which is 0. Okay? So 0 is one of those Hooy-Vach situations. Horizontal lines have a 0 slope and their equations are y equals. So your equation of one median is going to be y equals 10. Okay? So that's 1. Let's do the same thing with yz. All right? So we want the midpoint of yz. So that's 1 plus 5 over 2, and 5 plus 10 over 2. Eek, this is going to be gross. That's 3, and then 15 over 2. So if we're dealing with yz, okay, it's got to pass through this midpoint and point x. So we're finding the slope between those 2 points. So 15 over 2, I'm just going to deal with that as a decimal because that'll make my life easier. That's 7.5 minus 15 over 3 plus 3. Ew. What is 7.5 minus 15? Oy, oy, oy. That horrible thing. Okay, it's not that bad. That's your slope. All right. So then we write the equation with this slope that passes through this point. That's not so bad. It's just some pretty ugly numbers. Y minus 7.5 is equal to negative 1.25 times x minus 3. So okay, not so bad. Still kind of gross. Whatever, let's move on to xz. Maybe that'll be a little bit nicer to us. So again, midpoint. -3 plus 5 over 2, 15 plus 10 over 2. Yeah, God, it's not that nice. Whatever. This is 1, 25 over 2 is 12.5. So we're going to have to go through the same thing all over again. Let's see. Passes through this and this. So we're finding the slope between y and that. So 12.5 minus 1. 5. Oh, this is actually nicer. Sweet. Okay, because what happens is, as I think you can already tell, this is 7.5 over 0, which is an undefined slope. Yay. That means it's a special case. Okay? So this is the other part of the Hooy-Vux. Vertical lines have an undefined slope and their equations are x equals. So x equals 1. All right. I went through all this because normally what would have to happen is if you had, not necessarily all 3 equations looking like that, but if you had all 3 equations in your normal y equals mx plus b format, you could pick any 2 of them, set them equal to each other, and then solve like sort of like a system. But because we have an x and a y, when we're looking for a centroid, if we're looking for coordinates in general, we're looking for an ordered pair. So we're looking for an x and a y. Because we have 2 special cases of our equations of lines, one is x, one is y. This is your x value, this is your y value. All right, so it's not even that complicated. Your final answer is actually going to be 1, 10. And that's that whole problem. I know it was a mess. I think this is probably going to be an insanely long video, but I think it might help. Sorry. I think it might help to do another one of these just so we're all clear on what's going on, even if it does turn out to be like an hour-long video. Okay, so if we're finding a centroid again, okay, we're looking for the midpoint of HU. So that's 0 plus 4 over 2, 1 plus 3, 2. So that's 2, 2. That's your midpoint. And the slope, we're finding the slope of this midpoint and the only other point of these 3 that we haven't dealt with yet. So that's this 2, 5. All right, that's point P. So it's 5 minus 2 over 2 minus 2, which is 3 over 0. We've got another special case. So x is 2. Looks like it's probably going to be a similar situation to what happened with the last one. UP, the midpoint of UP, is 3, 4. All right. So the slope, we want the slope of this midpoint and point H. So 1 minus 4 over 0 minus 3 is negative 3 over negative 3, which is 1. Thank God this slope is a lot nicer to us. So real quick, y minus 4 is equal to 1 times x minus 3. So that's another equation. That's another median. And then HP, the midpoint. Two, 1, so that's 3. Okay. So HP, this is the midpoint of HP, so we want the slope between this and point U up here. So this looks like, yep, it's going to be another special case. So 0 over 3 is 0. So nice. All right. Y is 3. We've got our X. We've got our Y. Our lives are a whole lot easier now, I hope. There's your centroid. Okay. Okay, let's move on to altitudes. I think I've mentioned altitudes before. It's basically a fancy name for height. Like I've been saying a lot when we were dealing with triangles and right triangles and stuff, like when you drop your perpendicular height, a fancy name for that is just an altitude. All right. Formally, it's a perpendicular segment from a vertex to the line containing the opposite side. So it does also, like if I talk about QY down here, it does pass through one of the vertices of the triangle, but instead of being a bisector or passing through a midpoint, it's just perpendicular. So if you have to eventually write the equations of like where the altitudes intersect, let's say, you still want it to pass through the opposing vertex, but it's got to have that perpendicular slope this time instead of like actually finding the slope. Instead of like, what? Opposite reciprocal slope. That's the slope you're going to use. Passes through this point. I think we're going to get there at some point in this video. So the intersection is the orthocenter. All right. And actually, there's really nothing fancy about the orthocenter. All right. It's just the intersection of all three altitudes. That's really what this is saying and what this is saying. All right. Sweet. P is your orthocenter. So we're going to move on to that super, super fun stuff that I was just talking about with finding the coordinates of the orthocenter. Okay. So now we're going to kind of switch things up a little bit because we're talking about orthocenter. We're talking about altitudes this time. So we don't have anything being bisected. We just have some stuff that's perpendicular. So we're going to deal with slopes and then opposite reciprocal. So for example, if I deal with AB, right, I know the altitude that passes through this segment AB has to be perpendicular to it, which means the slope has to be opposite reciprocal. So I'm going to find the slope of AB first. It's 4 minus 2 over 4 plus 2. So it's 2 over 6, which reduces to 1/3. All right. The opposite reciprocal of 1/3 is -3. So that's the slope that we're going to use when we write the equation of the altitude that passes through AB. It's this slope that passes through the remaining point. So if we're dealing with AB, we're talking about point C here. All right. So y plus 2 is equal to -3 times x minus 1. And then we solve that for y. All right. That's one of our altitudes. Let's go to BC. The slope is, that's the slope of BC. Opposite reciprocal is -1/2. And it's this slope that passes through this point. So y minus 2 is equal to times x plus 2. All right, that's another median. Finally, AC. Its slope is okay. And so then the opposite, right? Yeah, I did that right. Yeah. So then the opposite reciprocal that we want is 3 over 4. All right. So this is our slope, and it's passing through the remaining point that we haven't dealt with yet, which is B. So okay. There you go. And, okay. This is, now here comes what the whole point of all this that I was trying to say like a couple problems ago. We don't have any special cases this time. But we do have 1, 2, 3 different equations that are all in terms of x and y. So we can pick any two that we want and set up a system. All right. I like these first two just because the numbers are slightly nicer. So I'm just going to put them off to the side. And the nice thing about working with these kinds of things is that they already have both set equal to y. So you can just, if they're both equal to y, then you can set them equal to each other. So -3x plus 1 is equal to -1/2 x plus 1. So, so again, fractions, whatever. The ones also end up canceling out. And then, really? Oh no, you have to, okay. Sorry, I'm like thinking on the top of my head here. You add 1/2 x to both sides, so this is -2.5 x equals 0. Oh, x is 0. Oh, that makes life easier. Okay, cool. Okay, so then when you plug it back into any of them, y is 1. So that means finally your, what are we looking for? Orthocenter is 0, 1. Yay, that was a lot of work. As usual, like a digital copy of this is going to go up on Classroom. So you'll have all this for reference in case you need it. I think, is this the last one? Yeah. I know we're approaching the half-hour mark. This is probably, if I didn't already say this, probably my longest lesson video up to this point, but it's kind of complicated stuff, so I want to make sure everybody has a really, really good handle on it. There are plenty of places for you guys to ask questions if you have them. But this problem is exactly the same as what we just did. So, we are going to find the slope first of DE. So that is 6 minus 9 over, okay, that's the slope of DE. Orthocenter, we're dealing with altitudes, which means we want a whole bunch of perpendicular stuff. So the slope that we're using to write the equation is the opposite reciprocal, which is 1. So we're using this slope. We're writing the equation of the line with this slope that passes through the remaining point, which is F. And this one's actually really nice because 0, 6 is a y-intercept by definition. X value is always 0. So y equals x plus 6. And DE, that altitude, was really easy. EF then, the slope is, okay. So we got some special cases now, thank God. Our slope is undefined, which means it's going to be the Hooy-Vaux x equals, and it's x equals, we're talking about point D, all right? So x equals -9. Slope of undefined that passes through the remaining point. All right, that's what we're talking about, D. X is -9. And then DF. So that's the slope of DF. The opposite reciprocal is 3. And we want it to pass through the remaining point, which is E. So we do have to do a little bit of work for that. That is y minus 6 is equal to 3 times x plus 6. All right. Now here's the nice thing about this specific problem. We don't have like an exclusively special cases. We don't have an x and a y, but we don't even have to set up a system for this because we already have our x value. It's going to be 9. All right. I'm -9. Sorry. And because we have two options now, we can honestly just plug this -9 into either one of these two equations and get our y value. I personally think this one is way easier to work with. I think you guys do too. -9 plus 6 is -3. Y is -3. Your orthocenter is -9, -3. And if you plug -9 in here, -9 times 3 is -27, plus 4 is also -3, so it does work. All right? So we are golden. Whew. All right, the only thing I have left here to finish this up is, you guys could see this on the digital copy. This is just a nice reference of everything that we've talked about over the past couple sections. This stuff comes from section 5.1, perpendicular and angle bisectors, and then these two were what we just talked about in section 5.2. All right, again, there are plenty of resources for you guys to ask questions if this was way too much or if it was like super, super complicated. There is the hangout, the big group hangout that we still have going. There's the question forum. There is the, you can still have video conferences. The slide thing to sign up is on Google Classroom. I would just appreciate, while we're on the subject of the video conference, like if you want to schedule a video conference, that's absolutely fine. I do try to check that sign up sheet as often as I can. I would just really appreciate it. Like, for example, let's say if you wanted to meet on video at like 1 o'clock, please don't sign up at 12:30. I'm not like picking on anybody. I'm just saying that would help my sanity if you guys gave me a heads up, so I knew to expect a video call with you, or a bunch of people. And yeah, we're past half an hour at this point, so I think I'm gonna cut it off here. But yeah, that's it. Talk to you guys soon.